pleasure to be here on this fascinating topics. So my challenge is, in the title of my talk, was duality, and I need to relate that to non-duality in order to be able to come to this conference. And the reason I have this problem is that since 1976, after there was some hippies that went to Esalen, and inspired by them, I got the California license plate of duality. And everywhere I look, I see Republicans and Democrats fighting with each other on different sides. I see, no matter where I look, I see dualities all over the place. My kids figured that out, and for one of my birthday presents, they gave me I can't take this. I'm wired. Oh dear. I didn't count on this. Okay. Shall I shout, or I could put it back on?
Yeah, we put it back on.
Okay. Anyway, so as they're maneuvering me, I'll tell you what my project is. What I'm here for is, as with all things, we want to be unitary. I'm a Unitarian, and I'm a Universalist. And so from dualities, we're wanting to get unity, and that's a major part of my talk today. That's, if I can achieve that, how to get consonance, how to get agreement, how to get people to agree on some topic, Republicans, and you'll see that building bridges is super important. Do I have a thingy, or should I just go and point? I can. So the things that we're going to try to make connections between duality and non-duality.
With this.
Okay.
The red is important. The red one.
Okay. But also, there are dualities between science and religion, science and spirituality, which is kind of what we are here, more spiritual, but also religion, I'm going to emphasize. Religion actually gets political things done in this country or other countries. And so there's various religions have dualistic, have contrarian. I don't know what's going on between the Shiites and the Sunnis, but there's a duality, there's differences. So how do we bridge, how do we build bridges? Well, entanglement is a kind of a bridge, and entanglement gets things entangled. Well, that could be good, but for progress to be made, I'm going to be emphasizing yoking. Yoking is getting people to work together. I don't know if you can see that this is the journal Zygon. Zygon is published by the Institute on Religion in an Age of Science that I'm involved with, and that is very important. So I'm going to go beyond. I'm going to spend a lot of time on entanglement, but people before me have done entanglement. So I'm going to, the finale is going to be how to do beyond entanglement and get to zygoning. It's the quarterly, I've already said that. Okay, so here's the schedule of the talk. First, I'm going to give you the standard lecture on quantum mechanics, in case there's anybody here who doesn't by now know all the details and the formulas and all of that, how quantum mechanics, and I'm going to do it Feynman's way. I'm very inspired by Feynman, and so you're going to hear that everything is particles. Newton was right. The photons is not a wave, but it's particles, and Feynman gives very strong, anyway. So that's, I'll tell you how quantum mechanics works, entanglement, blah, blah, blah. And then comes the bridge building. There's going to be this, well, you'll see this again. And now, why are we so interested? Why am I so interested in building bridges? Why am I wanting to yoke the religious people together to help the homeless, to do a carbon tax? Why are we trying to get society to behave? This is from Deepak Chopra. How do we go about creating a peaceful, just, sustainable, happier, and healthy world? So that's the purpose of the thing. And, oh, this is the previous slide. This is a little bit grayer. So this IRIS institution this is the 60th birthday of it. It was created in 1954 in Boston. It was Harvard and MIT physics professors who were fairly convinced that there was going to be a nuclear war. We were in conflict with Russia. They had bombs, we had bombs. There was and we had worldviews. They wanted to take over the world. We wanted to take over, blah, blah, blah. How was that going to get resolved? Well, the people in Boston thought what was needed was to get science and religion to work together. That the science folks maybe figure out how to make society work, B.F. Skinner working on how does society work, and the religion people motivating people to be their better selves, etc., etc. So we are now in the same state as we were 60 years ago with climate change. We have problems in our societies that we're going to need to behave better, and that's why I am here, actually. That's why I'm devoting time to building bridges, etc., etc. Yeah. Okay, so we're going to now begin the standard, what is quantum mechanics? Well, this is the Feynman way. It's something called path integral. It's a very dualistic thing. We may have a little discussion about what is an observer. We'll talk about that when there's time. But there is an observation. You start the experiment. That's kind of the observer starts it. Then when nobody's looking, here's an observation number one, here's observation number two, here's observation. When nobody's looking, and these are photons, so we're just starting an experiment with a photon here. When nobody's looking, according to Feynman, that darn photon is going to do every which little thing it can. It's going to make the double slit experiment that we heard about this morning. It's going to make that work. It's going to make every experiment that we know about work. And Feynman gives some rules. They're called Feynman rules for how to calculate. But it can take any path, and each path, I'll say each path. And then there's another observation. And so this can be done with photons. But this doesn't just have to be photons. It could be an atom. It could be a buckyball, a big 60 carbon atoms. They've done this with that. It could be a cat. So each of these could represent a cat, and this one over here could be an awake cat. This is not a dead cat. This is a sleeping cat. So some of these, and then every time there's an observation, all these possible awake or dead, awake or sleeping cats, when you make an observation, all these other possibilities collapse, and it's only this one. So then the next generation starts out here, then another collapse. Anytime there's an observation, there's a collapse. Does that make any sense? How many people think that this story makes some sense? How many think that, oh, okay, one person. How many think this is just strange? Strange. Oh, some people don't know. Well, okay, anyway, Feynman did write the book. The main book I'm going to advertise is QED, Quantum Electrodynamics, The Strange Theory of Light and Matter, how to connect light and matter. And he always would say, we don't have the foggiest. It doesn't make any sense, but it seems to be true because it agrees with experiment. And that's kind of delightful, that we have a theory that seems to be true. Oh, this is the Feynman rules, that when you're not looking, there's something called an arrow, and you calculate the size of the, so an arrow has a certain length, and Feynman gives rules. He gives, in the QED book, it's not, no equations, lots of pictures. The QED book has lots of pictures of arrows. The mathematicians will call them complex numbers with an imaginary, but he doesn't want to get so fancy. And then, so each arrow you calculate, then you add up all the arrows and square it, and that's a probability. And that's really pretty much all you need to know about quantum mechanics. Everything else, well, there are the rules that, and we can tell, well, I'll show you a little bit about the rules. But what happened about 30 years ago at Berkeley, there were some students, graduate students, who were not happy with the way physics was going. They didn't understand it, and they wanted to do deeper. And they started thinking about entanglement. They started worrying about the EPR, about entanglement. And the guy who wrote this, Kaiser, He should come here next year. He's an interesting guy. His mother-in-law is a member of my Unitarian congregation, so he visits here. Anyway, this is on the book jacket. An eccentric group of physicists in Berkeley explored the wilder side of science. They studied quantum entanglement through the lens of Eastern mysticism, discussing the latest research while lounging in hot tubs. So this was in the 70s of entanglement, mysticism, us. And so it's a group dear to my, and it was because of them, they met at SLN, and that's inspired me to get the license plate. I don't think I need to do too much on entanglement. You've heard enough about entanglement. We have something that, the original Einstein-Rosen-Podolsky was with something with two electrons getting entangled, but electron spin doesn't make sense, so I always like to talk about it in terms of photons with calcite or photomultipliers. Anyway, the photon, this is Alice. If Alice sees the plus sign, then the person on the other side, the other person also, whatever Alice sees, Bob will see the complement of it. And one of the things that is interesting, what does the entangling, who is the observer? It could be the photomultiplier tubes like on the previous, or it could be, if these are photons, these might as well be, might as well have the person looking at it, and then it will get entangled, then it will get detected. So now the question is, who is the observer? And it could be the mind, it could be consciousness. But according to the Penrose-Hameroff objective reduction, OR, where is it? Objective collapse. As soon as the photons, it turns out there's enough rhodopsins, the detection of a photon makes a big commotion in the retina. That's what I study now, is neuroscience and retina. There's a lot of stuff, and it probably, I've been in touch with Hameroff, that probably will do the collapse. It's in the brain, there's something called orchestrated that, with the microtubules that might delay it, but the collapse probably for this entangled thing might happen right in the retina without needing consciousness. Anyway, so here's a little bit more, same picture, but a little bit cleaner. So here's positive decay, here's the two photons, Alice. This is the Alice and Bob on one path where they're agreeing on this. Here's Alice and, this is vertical polarizations, Alice and Bob, here's horizontal orientation. So maybe this is the one that gets observed here, and so then Alice and Bob will both agree that it was the horizontal. So that's pretty much all I'll say about entanglement. That's entanglement by the Feynman way. But I'm mentioning Feynman, and so let's just focus on, here's a 3-vertex thing. Here's a positronium and 2 photons. Well, it could be 2, these could be whatever it is, but it's a 3-thingy vertex. And that's what physicists love. They love to calculate. This is the 8th order. There's 1, 2, 3, 4, 5, 6th order. Okay, 6th order. You can, for the magnetic moment of the electron, the best experimental value is known to be this thing, and the theoretical value, the calculation, this is the Feynman calculation, you have to calculate every possible, there's thousands of these Feynman diagrams for doing that triplet calculation. And they calculate it to be this, unbelievable accuracy. So quantum mechanics has unbelievable accuracy. When it's for simple things, when it's, shall I lift my hand now or now, that's a little bit complicated. There's a billion or trillion, there's a lot of neurons involved. But this accuracy is equivalent to measuring the distance from the Earth to the Moon to within the width of a single human hair. So quantum mechanics is unbelievably accurate and validated. And when people have tried, I remember when I was in physics, Steve Weinberg, a lot of people have been trying to fiddle with the rules to make the to make this reduction, this other step, the dualistic step of when people don't see and then you have an observation. And so people have been trying to fiddle to make it plausible. Every time you fiddle the littlest, teeniest little bit, this accuracy goes bad. You try to put in something at the bottom, change the standard model a little bit, the accuracy goes down. And so we're left with this delightful quantum mechanics that we all, I bow to it. Yeah, it's and this is the QED book that goes through how he again with no math, but I recommend that book. Okay, so now I'm done with part 1. So now, based on what I've just told you, that's pretty much all you pretty much, except for the little mathematical calculation. There's rules. For every little vertex, there's rules. For every line, Feynman gives a rule. It's a very simple thing. Just something like 8 years in graduate school, then you'll figure it out. Okay, so now we're going to do the bridging, the duality business. So how am I going to span how am I going to go from duality to non-duality? Okay, so the first thing we're going to do is the cut. Where is the cut? Who is the observer? How do you make an what? Well, okay, we need a device. A double slit experiment is here, and this is that little thing that I just showed you. This is a little quantum device. This quantum device is sleeping gas. It's not this noxious thing that the German, whoever it was, Schrödinger. This is Schrödinger's cat. Anyways, this is just puts him to sleep. So this cat is in the state of half being awake and half being asleep. And the observer, according to Henry Stapp, according to many people, it takes a consciousness, it takes a mind of a primate, possibly, maybe an animal, possibly, to do the observation. So this is the observer. Looking at, and when the observer looks inside this little window, when the window opens, then the cat is alive or is awake or asleep. So the rule, let me just repeat the rules. When no observation is made, the world moves according to the Feynman rules that determine, this is just to repeat myself. And then when an observation is made, the wave collapses to the real world. The probability of the outcome is proportional to the square of the arrow, the amplitude. And here's the thing that I drew. So one possibility is to put the split between you and you. So here's the observer. And then, I think this is what you had. It could be me out here looking at this person. This is me, this is Bob looking at here. It could be me who is the observer. And this is nifty because now this gadget is a thing that I can do my neuroscience on. I can stick needles into that guy and figure out the neurons and how did this person think that he was the observer. I can do experiments on him and think of him as an it or her as an it. And this is the me as a self, as something more than an it. Or what about this? I don't know if this was in your. We'll have to talk about. It might be that I'm not the observer. It might be that there's a little tiny network in my brain and prefrontal cortex. Though in the latest issue, this is one of my ads. Christoph Koch, this came this week. He has an article in this Scientific American Mind I highly recommend. In this one that just arrived, he has a new hypothesis, the claustrum, where there's a little sliver. It's too small to be seen by fMRI. It's very tiny. And it might be where consciousness does its thing. We don't know yet. Neuroscience has hardly learned anything. If you think neuroscience has made any progress in the last 100 years, the answer is it hasn't. It's done a little bit, but hardly anything. So right now, I hope you people are around for another 50 years because there's going to be some exciting things, possibly done by Christoph. He's in charge of the Allen Institute. Paul Allen now inherited half of the Microsoft fortune and is spending a lot of money on supporting Christoph Koch on doing things on the mice. Where, if there's time, I can tell you a lot about. Anyway, there's a lot more that can be said about why Christoph might be onto something. He can make mice brains transparent. He can make single neurons fluoresce optogenetically. Mice can be treated genetically. Okay, so the split is movable. So that's the answer for duality. Number one is that the observer problem is no longer a problem. The observer, and actually von Neumann at the last chapter of his book, written in 1931, proved that the split can be movable. And so there's no more issue of who is the observer because anybody can be the observer. The observer can be, I can be either observer or observed. I can either be, to myself, I'm a person, but to you, I could be a thing. So that was the building bridges. Oh, yes. Can an iPhone be an observer? Henry Stapp would say no. You have to be something special? Well, what is it? We don't know whether the iPhone, or what can we do to the iPhone? The Apple will have to figure that out. But maybe the iPhone can't be an observer right now, but maybe there's something called integrated information theory. The Tononi has a new circuit that might make the iPhone conscious. Anyway, so that is the end of the movable split. Now comes the next question of what in the world does quantum mechanics trying to tell us? What is going on? What does it mean? What is the interpretation when... von Neumann, there are philosophies and religions, different understandings of the metaphysics, yeah. What's going on behind the physics? What's the metaphysics? And the problem here is that all the theories, except for Penrose, that I'll come back to, all present understandings of metaphysics give the same answer. I'm just going to go through this very quickly because I think, how much time do I have? Oh, 20 minutes. Oh, okay, then we're okay. Okay. So anyway, there's Bohr. Anyway, there's a lot of different understandings. One of my favorites is Whitehead, because he came up with a notion of this is around 1925, 26, 27. His Process and Reality was published in the early 30s, or anyway, around that time, just when quantum mechanics was just starting. And a theologian, Hartshorne, got hold of it and made it into a theology. The Southern Baptists needed a theology, so the Southern Methodists, did I say Baptists? The Southern Methodists adopted Hartshorne's theory of process thinking, Whitehead's theory, and then that got passed down to John Cobb, Claremont. I spent my first 14 years teaching physics in Claremont before I came to Berkeley. And it became a very interesting, we'll get back to that. But all of these are based on pretty much the same data. All of them, it's hard to, well, Whitehead has some possible, there's a possibility that Whitehead, in fact, in Penrose's book, The Small, the Large, and the Mind, there's an article by Abner Shimoni. It's a very thin book that I recommend also. And Shimoni talks about process thinking, about whether there might be at the bottom something that now resembles the Penrose Hameroff, a Platonic something at the bottom. And process theology has that possibility in it. But there are some, in addition to these, there's one that is objective reduction that has different predictions, and actually Santa Barbara, University of Santa Barbara, University of California, Santa Barbara is actually building a satellite to test it involves quantum gravity, and it has different predictions that there actually might be actual collapses, not probabilistic things. The above ontologies are dualistic and more peculiar than the simple God metaphors. And yeah, anyway, so these are beautiful. They're all in a sense. When you read them, they're talking about a particle. The quantum particle is a metaphor. It's not like a particle of sand. It's a different thing, but we use that language. Now comes my most interesting slide of the whole talk. I recommend this to everybody. When you go home, or go to your computer, the first thing to do is Google interpretations of quantum mechanics. You'll get a whole bunch of things that are all worth looking at. The very first one is the Wikipedia thing on interpretations of quantum mechanics, and towards the end, it goes through all the discussions about all the interpretations, including the Penrose and the Stapp and all of that. And then towards the end is this table. This table, to me, I shiver when I look at it. It takes these are the 14 most popular ones. There's a little bit right above here in the Wikipedia, about 3 inches up, is less popular ones where we have God and God might do a thing, or the more bizarre. Anyway, there's a variety of less popular interpretations, all that presumably agree with the same data. So they're organized by year. So Born was 26, and then Heisenberg, even though he was in a little before, anyway, then de Broglie, Bohm. Each of these are different people. Max. If you actually look at the Wikipedia site, you will see that Max Tegmark and Aguirre, professor at UC Santa Cruz, have given themselves a slot separate from, but I put them together with Everett. Then on the vertical, there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 characteristics, properties. Like one of my favorite, hidden variables. Where's deterministic? Deterministic. Is it deterministic? Oh, these are all, is it real? They're all different. And every single one of these, except for the Tegmark, where was Tegmark? This one, Everett and Tegmark. This was the only one. If you actually go look, you'll see that there's 2 slots for this. One was in 57, and then down here at the bottom would have been Tegmark. Has the same one. So that really, they should have not made a special row, because this one is the same. But look at this. Each interpretation on the metaphysics, on what's going on underneath, are entirely different from each other. And they all, except for this one, objective collapse, that's GRW and Penrose, this is the only one, the objective, and this will all be discussed in the Wikipedia article, that this one is unique, that it does make different predictions. When the gravity is a certain strength, then there will be a collapse. All these others have probabilistic collapses. So anyway, so this table is, for people interested in quantum mechanics, it's a wonderful table. Okay, so that takes care of the interpretations part of my talk. The last part is the most important, at least for the future of the world, is how does the world how is the world made better? That's why I'm here, because spirituality, we're helping people live a better life. The meditations, the things that you're getting here are important to individuals, and it could be important to the world. So, in the center I have science. I'm a scientist, so I'll put that in the center. But the various things out here are different ways of interpreting science, of bringing it to the people, or how does it affect our lives? Taking knowledge. So the Old Testament was trying to take the best knowledge that they had, but that was a long time ago, so it was not fully correct. But taking the best, but how should we live lives? There's Abrahamic religions. There's naturalism. This is like Unitarianism and stuff. Skeptics, even they have religion. They have beliefs on how they raise children. Process theology is what I've mentioned. The Vatican is one of my favorite. And liberal theology. The Vatican, I'm using the word the Vatican rather than the Catholic Church. The Vatican has Vatican Observatory. The Vatican has a bunch of scientists. They're the intellectual branch of the Catholic Church. And they are no longer, the Galileo event got them to do better. The Catholic Church is fully evolution compatible with science. The Catholic Church is fully Big Bang compatible. They're all into multiverse. They're fully into whatever string theory says. The Catholic Church says, yeah, that's fine with us. That's how God did it. Yep, that sounds good. And that, a lot of people are not aware of that. Max Tegmark, actually, he's a guy at MIT, a professor, did a survey, his wife mainly did it, but anyway, they did a survey of lots of religions, and they found the Catholic Church to be one of the most science-compatible of all the religions. Okay, so this is now, I'm getting back to the IRIS, the Institute on Religion and Age of Science. For those who are into weird things, the philosophers and theologians who are interested in gender issues have adopted the word queer as a double meaning word, meaning both sexually different, but also strange and different. And they have taken postmodern. So this, to the shock of many of our IRIS members, is going to be a queering of anything. So they've taken the gender queeringness and questioning anything, including science. So we're going to have a year that some of us are worried about, where even our science is being questioned. We will explore such issues as how queer is the natural world? How might we blur the boundaries between and within the academy? My academy? What are the boundaries of the sacred and the secular, of reason and faith? Is God queer? Meaning strange. Ultimately, we want to have a queer religion, science, and blah, blah. So those, anyone interested in that organization, the issue again is how to connect science and spirituality, how to connect science and religion. And that's what science and non-duality, that's what this conference is about. So it's very important. It's a subjective real, I think this is just a summary of everything. Conflicting views, I think I've said that, maybe deep dualities are unities, how to connect the dualities. Oh, and the thing I didn't mention, these theologians that I was going to say that in the last slide, the theologians who are from UCC, at least the progressive theologians, which is most of the Methodists, Presbyterians, Catholics, the Jesuits at least, are understanding a lot of stuff as deep metaphor. It's not merely metaphor. Everything might be metaphor. Our whole world, the way we perceive the world is in terms of what is it like an act. Anyway, so there could be one of these things that comes out of the quantum mechanics. So here I am now at the ending of my thing. I'm going to now just go again on how everything that we've talked here and what Science and Non-Duality Conference is wanting to accomplish. How can we use what we get here to make this a peaceful, just, sustainable, happier, and healthier world? What do we do? What's our progress? So first of all, the notion of entanglement. This morning we did an exercise of looking, at the very beginning we looked at a neighbor's eyes. We looked at each other. We got entangled. You can get deep. I did this, this is in the 70s again. John Lilly, has anybody ever heard the word John Lilly? Oh, okay. So John Lilly was married, and this is in Lake Arrowhead. There was a conference, and Tony, the wife, we were paired, and the goal was to look at each other in the eye without moving, no facial muscle, but it was instead of just for 1 minute or half a minute, it was for 15 minutes. And try it someday. And it has to do with if you don't move your eyes much, some of the person's features will fade and they will morph. You will start seeing things, real observations in the other person. And you can do this with almost anything, but faces, we have whole circuitries with faces. And it was a freaky experience. But looking into each other's eyes, you can the brain will generate other things that you might have associations with that person. And anyway, we're all entangled. So that's one thing that quantum mechanics will give. So even though the truth of the matter is, and I object to some of the talks that we've heard on entanglement that make it real, the quantum mechanics has the probability of entanglement being really in a state of superposition is not. To be entangled, you're still in a superposed state. And that's pretty unlikely to happen. But as a metaphor, and to really believe that the person that I'm looking at, I'm entangled with, that I can easily do. And so somehow quantum mechanics legitimizes strange things. It's a strange theory, so it's okay if I believe in strange things, because it's possible. This is in the Tanzi. Is Tanzi here? Oh, he's somewhere in this building. He wrote a book with Deepak Chopra, Superbrain, and they had a discussion about how the beliefs, they call it a placebo. And so the placebo, scientists like that word. The placebo, even if it is not exactly mechanistically true, if you believe it to be true, it can become true. You can heal yourself with the placebo effect. But if you're an atheist and don't believe that prayer works, you're not going to get the benefit. So to be able to believe, to have the metaphor being true, is a pretty damn good way to bring about a powerful, just, sustainable, happier, and healthy world. So it's okay to have these kinds of faiths, even if you know that they're maybe mathematically not right. This came to me, this just came yesterday to the IRIS discussion group, and I'll just read the first paragraph. Under the surface of things and completely invisible to most observers, a great indirect negotiation is taking place, one with enormous implications for future course of... And this is the whole thing that's going on at this conference, that there are bridges being built at this conference between spirituality and science, going in both directions. Let's see, maybe each is realizing that they must reckon more fully with the other's incontrovertible truths. That means they're converging. We're talking about spirituality and science, heading for a marriage of sorts. This marriage, as it ripples through the world culture, is likely to mark an epochal culture sea change. And metaphors be with you.
We have time for one or two questions. Okay.
You were saying something about an article by Christoph Koch about in the journal Mind. And can you tell a little bit more about what the special beauty or interesting thing of that was?
Oh, you mean in the latest Scientific American Mind? Oh,
yeah.
In this issue, it was that there's one little brain region that there's a bunch of evidences of having some people with certain kinds of strokes that they have gone, no, I think this was with animals, where they can actually, so there's circumstantial implications that there's a teeny little region, the claustrum, where consciousness might result, where it's kind of a, do you know the global workspace theory, Bernie Bars and Stanislaus Dehaene? So there's a lot of communications between all parts of the brain, but how does that get organized? And it looks like the claustrum is a place where signals from everywhere comes in, and then it goes to some special places. So that's what that article is about. Scientific American Mind. It's the November-December issue.
Enjoyed your talk. I'm always interested in when you draw a great picture, especially one of complexity, which one of those many theories, if any, is your favorite? I mean, which one? Because we have to believe in something. So.
The simplest. I like the simplest, and I like, it's the von Neumann. So if you hear, Henry Stapp will be talking about that theory. The only difference with Henry that I have is that he wants to have it consciousness be doing the collapsing, and I'm open to it being a camera that does it. But I like the von Neumann interpretation because it's so simple. That's what I drew on the pictures, that there's an observation, then there's the evolution of the wave function, and then there's a collapse, and then evolution. That's the von Neumann.